Okay, I'm just going to talk to you very briefly about roof angles and your roof space height, because we haven't looked at that yet. So on a previous example we looked at eaves, and the calculation that I did then, which won't be the same as yours, came up with 600 mil for the eave. So I'm going to work with a 600 mil eave, and I'm going to work with a 2.4 meter ceiling height. So how do we now figure out that roof space height if I'm going to use, say, a 34-degree angle for my roof pitch? You're going to have to figure out what roof pitch you're using. I'm going to use 34 for my example, but I'm going to try and use something optimal for my solar panels to work. And you would want to see what that is for Sydney. Look it up. In fact, if you look through the notes I gave you with the assignment, you'll find some information there. Okay. Now, sorry about that. So if you have a look at this diagram that I've drawn here, along the bottom there I've got half of the 9 meters, which is 4.5, but then I've got the eave, which is 600. So that's along the bottom of this triangle, because what is this triangle I'm drawing? Let's have a look up here. It's actually this here, this triangle there. Can you see that triangle is really what I've drawn? And the height is what I'm trying to figure out. I've used an angle of 34. Well, I'm going to use SOHCAHTOA because this is a right angle triangle. And I'm going to go tan 34 is h over 5.1. So if I multiply both sides by 5.1, as we know we do, so multiply by 5.1, multiply by 5.1. The reason we do that is because that cancels that out. That'll give me h is 5.1 tan 34, and on my scientific calculator that gives me 3.4 meters. So for my particular sample scenario, I've come up with a 3.4 meter roof space. So when you're drawing your eastern elevation, or your northern for that matter, you'll know now, you've figured this bit out here, that 3.4 is that bit there, so you'll know how to draw that on your scale diagram. Okay, hope that helps, guys. Thanks.